this time I didn't bring a suit, because I see that there's a lot of people that are willing to learn in this room, which is extremely important in this session, because I'm going to challenge your system to think through some very difficult problems. And I hope that your system one, as Dave was talking about this morning, will not jump up and say, you're crazy, this can never work, because that is actually what mostly happens when I talk about no estimates. So a word of warning as we start. This will be hard to understand, and it will challenge certain things that you've always believed were true. If you're not ready for that, you're of course welcome to come and challenge me after the session, but don't throw tomatoes or eggs during the session, please. All right, so my name is Vasco Duarte. You can reach me in any of these different social networks or even email. Yes, I also do email, although that's not my most favorite method of communication. I'm on Twitter, so please do engage, ask questions. I find that the conversations we have on Twitter have a much larger impact than the conversations we have one-on-one, because we have an audience. There are other people involved. And I think that's one of the important things we should be fostering in software development. The truth is that software development on a massive scale is very recent. There's a lot of things we don't know. And this talk is about exploring one of those that we don't yet know how to handle. So I'll be talking about how to improve estimates, but I'll be talking about from the perspective of no estimates. So obviously there already is a paradox, and you will see why this is important. This is a tweet by Paul Klipp of Lunar Logic fame, who got already cited several times today. And his tweet was, most backlogs are waste. How many of you agree with that first statement? All right, I see it's going to be a tough challenge to get you on board. So what he's talking about is that a lot of the things we put into backlogs actually either never gets implemented or gets so significantly changed that the original story or feature in the backlog is no longer represented by the new content that is in the backlog. That's what he's talking about. And Dave talked about in his keynote about a 50% discard ratio. 50% of the requirements we come up with never actually end up in the running software at the end of the project. So if that data is correct, please bring up your system twos now. If that data is correct, then we have to assume that about 50% of the work that is done managing the backlogs is waste. Now we can go into a discussion about whether it is necessary waste or unnecessary waste. We'll have that discussion later. But it is true that they are waste. Now think about this as when you estimate those backlog items, it is therefore super waste because you will be estimating items that will never get implemented. How many of you have experience with the so-called planning poker? Okay, quite a few. Why I say so-called planning poker is that if I call it planning poker, I'm breaking a trademark. McConnel owns that trademark. You cannot use the term of the so-called planning poker in its original trademark form without breaking a law in the US, even though you are in Croatia. So be careful. So estimating backlog items that are never going to be implemented, and as you have experience with the so-called planning poker, it can be a very demotivating, frustrating, but mostly boring experience to go through a backlog of 100 items and try to fight with the other person. No, this is a 5. I've told you 1,000 times. This is a 5. I did this other one, and it was a 5. So this one is also a 5. No, it's not. It's a 3. I did it yesterday. Right? These discussions are totally useless. Yet they are where we spend most of the time in backlog estimation meetings. So it is, therefore, super waste. Revising backlog estimates, however, is already in mentally deranged territory. I think that after this introduction, it's quite easy to see why that is. Now we can start talking about the actual content, right? So I'm going to talk about how you can predict the release date of your project without estimating. Right out of the bat, how many of you even believe that this is possible? All right, it's going to be a tough one. So let me just start with a very short story. I am proud to be part of the Agile community. Many people have contributed to change the world. Many people have fought the proverbial windmills. How many of you know who these two characters are? Excellent. Don't need to explain. So that's a bit how I feel when I talk about no estimates, a bit like Don Quixote. I'm not sure I have the absolute truth, but I definitely see a giant. Right? It might be a giant, it might be a windmill. I believe it is a giant. But I'm working on a community, and I'm participating in a community that has people like Kent Beck. When Kent Beck introduced extreme programming, people called him crazy as well. People said, what? Test-driven? How can you write a test if you don't have any code to test? What do you mean by test-driven development? And having the customer on site? Are you crazy? They would see the crap we're doing. He changed your world. The reason why today software development is, for example, or has developed the craftsmanship movement is because of guys like Kent Beck. He changed your world. Software is much better because of this guy and the other people who developed extreme programming. It was not only him, but I'm using him as an example of a person who changed our world. My world today, working in software development, is totally different thanks to Kent Beck. Another guy who changed the world was this gentleman over here, Ken Schwaber, playing the bear pose. That's him playing the product owner. Hey, some people got it. And he changed our world. When he and others introduced Scrum, again, others were also involved, I'm using him as an example, they fundamentally changed the world we view software development. They introduced a process that was part of the lightweight methodologies that were discussed in the 90s. But it became so popular that today you couldn't kick a rock without hitting a Scrum Master. He changed your world. But of course, he was not the only one. Taishi Ono, whom I'm sure Håkan will be talking a lot about this afternoon, he changed our world as well. He created a completely new way to look at industry through his practice. He changed the way Toyota produced cars, and therefore created a new system of manufacturing. That Toyota production system that he helped create changed our world. If you don't believe, ask GM, because they almost went bankrupt twice. Another person that changed our world was Edward Deming. Edward Deming was an American that was basically kicked out of the States and sent over to Japan because, you know, we need to rebuild the Japanese industry, and it's a job you could do. We're fine here. We don't really need your teachings, because the guy was, you know, he was like a bear or a tiger or a lion. He was constantly telling American managers, you suck. And of course, managers were not very happy with that statement, so they sent him over to Japan. And irony of ironies, he transformed Japan in the most productive, the highest quality manufacturing industry in the world. So the guy that the US kicked out kicked the US's butt. And this is still true today, right? He went to Japan after the Second World War, but still today, Japanese companies are far ahead. Not all of them, of course, but some of the Japanese companies that applied his teachings are far, far ahead of their American counterparts. He changed our world by changing Japan. Because today, everybody wants to copy what he did. Of course, we could have a long discussion about not everybody understanding what he meant, but that's another presentation in of itself. So I am proud to be in this community, and what I'm presenting here is not something I came up with in isolation. It is built on what all others have done. But I do believe this one thing. What I'm going to present here today will change your world. Now, of course, you might have different perspectives on how that change will happen. Please do not engage your system ones right now. But I believe it will. And the reason why I think it will is things like this. We used to use these UML diagrams to design software. How many of you use these things on a daily basis today? Very few. In most conferences where I go to, including traditional conferences, almost no one uses these things anymore. Yet, when I started, if you didn't have one of these, you were not credible. Another thing that has happened because of these changes is that we don't look at coders like this anymore. We don't look at programmers as code monkeys. That was the term we used in the 90s. Actually, little known fact is that most programmers today are humans. This is an example of how this change drives resistance, but resistance that is fundamentally uninformed. Today, we don't look at Agile as chaos. But this is a book published by Barry Boehm and Richard Turner with forewords by Grady Buch, Alistair Coburn, and Arthur Peister. And look at the title, Agility and Discipline. Today, anyone that has done any Agile project knows that you have to be a lot more disciplined to do an Agile project than you needed to do a waterfall project. So is agility chaos? I don't think so. But that was a huge change. When we started talking about agility, it was seen that way. It was seen as chaos. And now we see that PMI, for example, is jumping in on the bandwagon because they clearly see the world has changed. They are the latecomers, they are the late majority, but they already understand that without Agile, they will lose their business, which is selling certification, by the way. Why? Again, because you can't kick a stone without hitting a Scrum Master these days. And soon, PMI wants it to be, you can't kick a stone without hitting an Agile project manager. That's what they are trying to do. So we're beyond the chasm. When we talk about crossing the chasm and reaching the late majority, we are beyond that. Because the world was changed because of all of those people that worked in many different ways, in many different aspects of what we call today software development. So no estimates. When I talk about no estimates, by the way, you can just Google it. If this is the first time you have encountered the term, you will find a lot of content, videos, blog posts, and so on about it. When I talk about no estimates, this is what I'm called. I'm an idealist, an extremist, and I'm chaotic. But in my view, no estimates is purely about applying these two values of the Agile Manifesto. Customer collaboration over contract negotiation and responding to change over following a plan. That's what no estimates is about. It's about finding ways to apply those in a very practical and pragmatic way. Just as an example, when you estimate, you need a plan. You can't estimate an abstract piece of work. You have to look at what is going to happen. And one of the things you learn as a project manager, if you go through the traditional training, is that you have to have a sequence of tasks, and you have dependencies, you fill in the buffers, and so on, and then you get your estimate. So actually, estimating means you're getting married to a plan, which, by the way, is wrong, even when you start. You don't know what parts of it are wrong, but you know it's wrong, because you've learned through experience that plans always change. But when you estimate, you're marrying yourself. You're putting your handcuffs and saying, we are going to implement it in this way and in this time frame. That's what the estimation process does to you, even though advocates of estimation will not talk about it. But that's a very clear consequence. Another aspect which I believe is extremely important is focusing on value. When you estimate, you are estimating a piece of work. That piece of work has some meaning, i.e. you will do X and not Y. You will implement a structure, an architecture in a certain way and not in another way. You're making commitments before you need to make those commitments and before you have enough information, or at least more information, that you can find out during the project. Therefore, by estimating, you are suffering from what is called goal displacement. Your goal, when estimating, is to define upfront things that you need to do later, not to find what is valuable for your customer. And when finally your understanding of value for your customer changes, because it will change, you're screwed. Why? Because you estimated. And now in order to change that, you have to go back and re-estimate everything. Mentally deranged territory, as Paul Klipp said in that first tweet when we started. So in my view, actually, NoEstimates is very easy. It's so easy, I can explain it to you in 4 steps. First step, select the most important piece of work you need to do. Typically, most teams that I work with, and even most companies that I work with, they know the answer to that first point. Now, some of them need some help to get there. But once you help them go through the thinking process, engage their system too, they actually get to that. They get to what is the most important thing we should be doing now, right? Once you do that, you break that work down into risk-neutral chunks of work. Now, I do want to be clear about what I mean by risk-neutral. Risk-neutral is something that if you're wrong, does not destroy your project, right? So one very easy way to explain is that if you have a project with only one requirement that takes 6 months, that's not risk-neutral. Why? Because either you have it or you don't have it, and if you don't have it, you're dead, right? Game over. So one very easy way to explain a risk-neutral chunk of work would be to break that one requirement down into increments of, let's say, a few hours, or even a day, right? Because if you're wrong, when will you know it? Tomorrow. And tomorrow you can react to that knowledge. You can adapt. And that's a very important part. Then you develop each piece of work, and then you iterate and refactor. I added step 4 because it's extremely important. Your first implementation of a particular solution should not be the last implementation of that solution because you haven't yet exposed it to your customer, right? So it's not just about implementing every single requirement, or in our case, we hope user story, but it is about also understanding how that user story fulfills the customer needs, i.e. what is the value of that piece of work. And that's what iteration means. Iteration does not mean developing one big requirement in many small user stories and then delivering the one big requirement in one go. Iteration means developing every user story, showing it to the customer, getting feedback, redevelop or change the user story with the knowledge you just acquired, and so on and so forth. So this is also a very important part of it, because with NoEstimates, one of the things we say up front is that until the customer has said yes, you have not delivered anything. It doesn't matter how much code you wrote, it doesn't matter how much testing you did. If the customer has not accepted the work, it is not completed. And this is a very important part of NoEstimates. We'll explore why later. In order for us to apply NoEstimates, however, we do have to answer one key question. Is your system of development stable? Now, system of development is a new word. I have to explain this a little bit. A system of development is a system that incorporates all of the work and all of the structures that need to be engaged in order to take one idea to your customer. So a system of development is not one team. A system of development is everybody involved that delivers value to your customer. I'll give you a concrete example. If you have a one-team organization, just one team, that one team is not enough to finish the work, right? You need to have somebody who collects the requirements or stories from the customer side, and you need to have somebody who shows the value to the customer, collects that feedback, and feeds it back into the team. Now, the team could do that if the customer is on site, but for example, if the customer is not on site, you need somebody to do that. That could be a customer insights employee, that could be just walking over to the customer and showing the product and getting the feedback from the customer, in which case that person that does that work is part of the system of development. So a system of development is something that includes everything that is needed to get one idea into the customer's hands. It's not just the development team. It's not just the business analysts. It's not just the testers. It's everything. This is an important distinction, because what we want to measure with NoEstimates is not how many user stories you've implemented. It's how much value you've delivered to your customer. Because the project only ends when you deliver the value the customer requested. So we need to look at the whole system, from beginning to end, from idea to customer delivery. So how many of you have been in this situation? Only 2, 3, 4, 5, it's going up, 10. All right. This is a very common situation because the moment you give somebody a number, they will want more of it, right? I mean, if the number goes down, when the number goes down is better, they will ask less of it. When the number goes up is better, they will ask more of it. This is what this manager here is doing. He knows that more user stories means better things, so he wants more user stories. Now, imagine that he came to you with this request, deliver 10 stories in the next sprint, but this is your team. This is your team, right? The blue line is how many stories you've delivered every single iteration for the past 21 iterations, right? So between 1 and 5, the best one. So between 2 and 4 is pretty clear you're going to deliver something along those lines. But now he comes in and he asks you, can you please deliver 10 stories in the next iteration? What would you say? Now, why is this important? We recognize that a particular system, and now I'm talking about the system of development, has an implicit capability. This particular system can deliver between 1 and 5, or even between 0 and 5, but mostly around 3 stories per iteration. This is a system of development, includes the whole chain from idea to customer delivery. It makes no sense to ask the system to deliver more. It makes no sense to set a target above the capability of the system. But when we estimate, this is what we're doing. It's impossible to avoid. Because even we as developers, let's assume we are all developers, we want to deliver more, right? So when we estimate, we always inherently have these biases. Oh, if we did this shortcut, maybe we could deliver more. And of course, we typically take the shortcuts, but we deliver less. So, the real question for us in the NoEstimates community is to answer this. Can we use the data we observe in the system of development to predict the system throughput and detect changes that affect system stability? Because if your system is not stable, remember that this system was stable, and you could see that it's stable, but there are some reasons or there are some situations in which the systems lose stability. We can discuss why those things happen, but it is important to recognize they do happen. So we need to know either that the system is stable and what is their capability, because then we can predict how much the system will be delivering over the next X iterations. And we need to detect when the system is not stable anymore, because when it's not stable, you can't use the data to predict future delivery. So we have developed 2 system rules. These system rules are based on statistical process control, but they are heuristics. This is not mathematics. This is about empirical application of these ideas. The first rule is if the velocity of a team is outside the limits, which were those blue and green line, red and green line, if it's outside the limits for more than 3 times, 3 or more times, then we have to say we don't know what is the actual capability of the system. We have an idea, but we can't be sure. The second rule is there are 5 or more points in a sequence. I mean, 5 points that go up in a sequence, 5 points that go down in the sequence. Those rules are important because they are an alarm, basically. They are a trigger for you to look at what is happening within the teams. Maybe a new developer was just hired, and he brings in a lot of knowledge that the other team members didn't have. Therefore, the capability goes up. So we have people that are developing faster. We have a team that is developing faster. But it could also be down. Maybe we just fired half of the company, and the teams that were left were not very happy. So they are, passively, aggressively letting you know that this is not going to work. These rules are just part of a whole system that we can talk about in a NoEstimates intro class. So if you're interested, just email me. I can give you the details on that. So now the question is, has this been applied in practice? Can we really look at a system and see that it's stable? And my question was, can we look at the project and observe its stability after the project ended? Right? This is looking at different projects, 4 different projects here, and none of these graphs breaks those stability rules, none of this. And there's another 4, also don't break the stability rules. So what this tells us is that for these 8 projects, you could have used the approach I just described to know when a particular amount of work would be delivered. You could use NoEstimates to predict the delivery date of the project. So basically, what I'm claiming here is that NoEstimates delivers. It gives you information that you cannot get with estimates in a reliable manner. But I want to give you a bit more concrete example. So let's look at a concrete example where we compared the effectiveness of predicting future throughput between story points done with the so-called planning poker game and just NoEstimates, which was done in a way that we just counted the number of stories. We did not size them, we just counted them. This is a project with 24 sprints, so it's not a small project, which helps us because it helps us to look at a long period of time and ask, is this predictable over a long period of time? And we asked this question, which of these metrics, story points or just counting the number of stories, predicted the output most accurately? We did this in 2 iterations. We took the average of the first 3 sprints and then the average of the first 5 sprints. Why 3 and 5? 3 is a good number because it's small enough so that you could tell your boss, hey, give us 3 iterations and then we'll tell you exactly when it's going to be done. Right? That's a good number. 3, it could be 3 weeks, which is not bad. Sometimes estimation processes take a lot longer than 3 weeks. How about having software delivered and knowing when it's going to be delivered in the end? That would be a plus. That would be an improvement. And then 5 sprints because the rationale was maybe we can even get better once we have more data. Maybe that tells us more about the capability of the system. So we did these 2 questions, 3 and 5 sprints. So, of course, I do have to give you a disclaimer. This is only one project. It's anecdotal evidence, but we have 22 more projects in this bit.ly link, NoEstimates Projects DB. So you can go to that link and you have an Excel sheet for your own use. You can take the data and do whatever you want with it, including challenge my conclusions, right? That's what I would like to happen, is that more people look at this, more people challenge these conclusions. And we have data for it. There are 23 projects now on that spreadsheet. So what happened after 3 sprints? This is the story points. So the true output of the system was 349.5 story points. Don't ask about the half. They just used halves in that project. I don't know why. The predicted output, if we had used the average of the first 3 sprints for that particular system of development, would be 418 story points completed. So if you took the average of the first 3 sprints, multiply that by the next 21 sprints, which was how many sprints were left, you would get 418, but the delivery was 349.5. So what this tells you is that if you used story points to predict when the project was going to be done, you would be 20% wrong. Now, let me be very clear about this. 20% wrong is a hell of a lot better than waterfall projects can do. Right? I'm not saying 20% is bad. I'm just saying this is what they showed. Of course, I do have to add that it was 20% in the wrong direction, i.e. if you had followed that estimation, you would have been late 20%, which is never good, but 20% is not that bad as an absolute delay to the original estimate. How about the number of stories? How about if we use NoEstimates? What was the result? So the true output was 228 stories. 24 sprints, 228 stories. The predicted output by using the average of the first 3 sprints was 220 stories. In practice, this is an error of 4%. So 4% is a lot better than 20%. We all know that, right? But it's 4% on the right side of the error, i.e. if you had used this estimate, you would have been 4% early compared to the original estimate. So in this particular point, 3 sprints, definitely number of stories was more accurate in this project. Now there's 22 other projects you can go and explore. But how about 5 sprints? Did we get better with 5 sprints? Was estimation any better when we had more data, when we had 5 sprints of data? So story points predictive power. 349.5 was the actual output. 396 story points completed was the prediction if you use the first 5 sprints. That's a 13% error. Now, 13% is even better than 20%, and a hell of a lot better than most waterfall projects can do today. So if you're doing story points, you're not completely lost. But how did NoEstimates perform in this particular example when we had 5 sprints of data? The predicted output was actually the same as for 3 sprints. Now, I do want to say this because people have asked in the past. This is not, I'm not just copy-pasting the graph. This is the actual result. When you took 5 sprints data and multiplied that by the 19 sprints that were left, you got 220. So it's the exact same number. It's just a coincidence. I'm pretty sure that if you do this for another project, take the first 3 sprints and then the first 5 sprints, you're not going to get the exact same result. But in this case, it was, and it was again 4% on the right side, meaning that if you had used that estimate, you would have been 4% earlier. When was the last time you did a project where estimation was crucial and you were 4% earlier than what you thought when you started the project? Anyone? No. I've never been in a project that was earlier when we were using estimates. So, the metric that was the most accurate, and let me just be very clear about this, the story point metric was pretty darn good compared to waterfall estimation. But you did have to spend all of those countless hours estimating, right? You did have to go into mentally deranged territory and revise estimates on your backlog. And have a backlog of maybe 50% discarded elements where you spend time estimating those elements. You would not have needed to spend that time if you had used NoEstimates. That would be time you could use for your own benefit. Go to a conference, for example, read a book, or develop more stories. So definitely the most accurate metric in this example, again, reminder, this is anecdotal evidence, was NoEstimates. But there is more. This is a graph by Corey Foy. He's plotting on a graph of story point sizes. You can't see it, but here is 0 story points, and here is 100 story points. And he has these black lines that go up that tells you the minimum cycle time and the max cycle time. So for 0 story points, cycle time was 200 days. This is days, by the way, not hours. So a story of 0 story points was delivered 200 days after it was started. This is actual data from a project he was working on, or he's still working on, I believe. If you look at, for example, 2 story points, the variation is between 0 and 50, so much better, and so on. But you see the green triangles here at the bottom. And look how they are close to each other, no matter how many story points were assigned to that particular story. And get this, the triangles are the average cycle time. So what does that tell you? Regular estimates have a variation of between 0 and 270, right? The 2 was much better, but the 8 was all the way almost up to 300. NoEstimates has a variation of about maybe 10 up to, let's call it 50. If you had been using NoEstimates in this project, your error, your margin of error would have been much, much smaller than using story points. And the irony of this is that if you look at 40 or 100 or even 20, you see that the 8 story point stories take on average about the same time to develop as the 20 story point stories. How do you like them apples now? Right? You spend all of that time arguing what's the actual accurate size of a particular story, and when you look at the data goes and says it doesn't matter. They're all the same size. So why do that? Why spend so much time estimating when the actual data in this one project tells the team that your average cycle time, i.e. the size of the average story in your backlog, is exactly the same no matter how many story points you attributed to it? So obviously in this particular example, which one is more predictable? Quite easily, NoEstimates approach would have been much more predictable because there's less variation. Okay, so let's take third and last example. This is a team out of Microsoft, and they looked at the difference of using different story points for the same stories. They started by looking at what does our release date look like if we used 1, 3, and 5. So they were already much closer to what we would call NoEstimates because they didn't have the whole range of story points. They had only 1, 3, and 5. That's it. Only 3 possible sizes. And they looked at their release date, cumulative flow diagram, projected the lines, release date on the 20th of October 2014. 1, 3, and 5. 1, 3, and 5 story points. So they took the data and they asked, okay, what if we have 1, 2, and 3? So we take the 1s, keep it as 1s, take the 3s, replace all 3s with 2s, take the 5s, replace all 5s with 3s. So you just change the estimate, just like that. What's the impact on the release date? 14th of October, 6 days earlier. Wait a minute, there's almost no difference. We're told that estimating is important. How come changing the estimate has almost no impact? So they did the obvious next step, and they gave all stories 1 point, i.e. using the NoEstimates approach. What was the release date that they came up with? 29th of September 2014. So all dates within 3 weeks of each other in a 38 to 42 week project, a margin of error of 8%. So Bill Hanlon was the guy at Microsoft that shared this case study with me. And he basically said in his email, at that point, I stopped thinking estimating was important. He didn't believe me. He did it on his own. He went and he experimented. He checked what the results were, and he found out there's an 8% difference between using estimates and not using estimates. Why the hell are we spending a lot more than 8% estimating our tasks? We gain all of that time back just by not estimating. We talked about what is a good estimate. These guys in '86 already said that if you're within 25% of the actual results, 75% of the time, you have a good estimate. But we've already seen in this presentation examples that outperform what the specialists consider good estimation. What the hell are we arguing about then? Right? Why is NoEstimate so weird? Because we've already seen examples that are better. Oh, and one more thing before we go. Let's look at what real projects look like. Chaos report. 80% late or failed projects. This is in Steve McConnell's software estimation book. Of course, he says the larger the project, the bigger the problem. The larger the project, the more delays have an impact on the project because they accumulate and so on and so forth. Now, we know that. That's why we use iterations in the first place. Break stuff down into smaller chunks. Second step of the NoEstimates approach. Break work down into risk-neutral chunks. Here's an actual company. This is the perfect accuracy line. This is the target completion date, and this is the actual completion date. All of these pink crosses here means the actual relationship between actual and target. Now, if this is the perfect line, the more up you are, the worse the estimation was. And look at this line here, this cross here. It's about 270 or 265 actual days with an estimate of about 7 days. This is how good we are at estimating. The truth of the matter is that we suck at estimation. And if your own money would depend on it, you would not spend 1 second estimating. But you do, because the people who think they own the money ask you to. But they don't really own the money, because the people who really own the money, i.e. the owners of the company, if they knew that you were doing this kind of results, they would fire you all. I would fire you all. Look at this. I'll jump a couple of slides here. This is an example from a company that did an evaluation of 17 different projects between 2001 and 2003. The average delay to the initial estimate was 62%. i.e., if they said that the project would cost 100,000 euros, it would end up costing 162,000 euros. Can you imagine making a bet, an investment that would have that kind of track record? Would you invest in a stock that you knew from the start would lose 62% of its value? No. This is actual data from real companies doing real software. This is not me arguing about which is best. This is the data. This is what data tells us over and over and over again. We suck at estimation. And it's unbelievable that guys that are as credible as Steve McConnell continue to sell us this idea that we should estimate better, because the track record isn't there. There is no good track record for estimation. Of course, I'm sure you will find 1 or 2 or maybe 5 or maybe 10 project managers who are very good at delivering projects on time. But then look closer at how they do it. It's not because they were good at estimating. It was because they were good at managing the project. And those two things are totally different. You can be good at managing your project without needing to be good at estimation. So my last message to you today is, don't believe me. Challenge me. Take the data that I just shared and evaluate it. Look at your own projects and evaluate your own projects with the no estimates approach. Try it out. Learn from it. Maybe it makes you a better estimator. If that's the result, you haven't lost anything. But maybe, just maybe, some of you will figure out that actually no estimates is a hell of a lot better alternative than what estimates have offered so far. Thank you very much. So I know that all of you want to go to lunch. I'm very happy to continue this conversation over the next day and a half and also over lunch. I have this talk written down for those of you that prefer to look at the details and read through. You can get the talk by going to that URL over there. You'll get an email from me with the PDF of the content of this talk. But I think now it's time to have a break, have lunch, and let's continue the conversation. Thank you.